They don't write the books, but make sure you can access the information you need. Let's now explore how mirror node subscriptions work. So, in this slide explains how clients can stay updated with Hedera's data. Clients subscribe to specific topics via the Hedera Consensus Service, HCS, choosing to receive notifications about transactions, accounts, or tokens. Mirror nodes listen for relevant events, filter them based on subscription criteria, and store the data locally. This setup allows businesses to get real-time updates tailored to their needs. For instance, a financial institution might subscribe to transactions involving a particular account to monitor payments. The process is seamless. Clients send subscription requests via REST or gRPC, and mirror nodes publish updates as they happen. This subscription model ensures businesses can react quickly to changes on the ledger, enhancing their operational efficiency. It's like setting up news alerts for only the stories you care about. Let's now see how mirror nodes takes this step further with notification. Once the client subscribes to an HCS topic, mirror nodes actively notify them when relevant events occur. The process starts with the mainnet sending an HCS message to the mirror node, which filters it based on the client's subscription, say transaction involving a specific token. The mirror node then publishes the message to subscribed clients via REST or gRPC. This is a game changer for real-time applications. Imagine a retail company getting instant alerts when a payment is confirmed, allowing them to ship goods immediately. Mirror nodes ensure these notifications are timely and precise, bridging the gap between the mainnet's consensus and the client's needs. This functionality is what makes Hedera so powerful for enterprise use cases. Now we'll explore how Hedera integrates with broader business networks. So this slide highlights Hedera's role in enterprise ecosystems. The mainnet handles consensus, ordering, and proofs, ensuring transactions are secure and final. But the state, your accounts, tokens, and files lives on business networks operated by collaborating parties. These networks can leverage Hedera's consensus for applications like Hyperledger Fabric, R3 Corda, or cloud-hosted services. This separation allows businesses to maintain their own data while benefiting from Hedera's speed and security. For example, a consortium of banks could use Hedera to settle cross-border payments in seconds, with each bank managing its own applet. Plugins make integration with these platforms straightforward, ensuring Hedera fits into existing enterprise stacks. This flexibility is what makes Hedera leader in DLT. By DLT, I mean distributed ledger technology. Let's now see how it integrates with message queues for even more functionality. So Hedera integrates seamlessly with message queues like Google Cloud, Sub, AWS, and RabbitMQ, allowing organizations to incorporate Hedera consensus into their existing workflows. For instance, Organization 1 might use Google Cloud to publish transactions to Hedera, while Organization 2 leverages RabbitMQ to process them. This interoperability ensures Hedera can slot into diverse tech stacks without disruption. Imagine a logistics company using AWS to track shipments on Hedera, with real-time updates flowing through their message queues. This integration makes Hedera a natural fit for enterprises looking to adapt DLT without overhauling their systems. It's all about meeting businesses where they are and enhancing their operations with cutting edge technology. So, to wrap up what we have seen, we've explored the robust architecture of Hedera Graph from its mainnet nodes, which deliver lightning fast consensus with ABFT security, to its mirror nodes, which provide scalable data access and real-time notifications. We've also seen how Hedera integrates with business networks and message queues, making it a versatile solution for enterprises worldwide. So, whether you're in finance, supply chain, or even healthcare, Hedera offers the speed, security, and flexibility to transform your operations. So before I continue to dive into this training session, I want to ask you all if you have some questions that going around the architecture of Hedera. So if you have any question, you can drop them into the Teams chat and also mention if it's clear for you so that we can continue. Now I'll take a quick look into the chat. So even if it's clear, please mention that it's clear so I can know that, okay? So thank you, Dolphin and Amani, for your interaction. I noticed that Miriam has wrote a question into the chat. So how does Hedera's architecture differ from traditional blockchain architectures like Bitcoin or Ethereum? So I'll explain you how. Hedera's Graph's architecture is fundamentally different from traditional blockchain architectures like Bitcoin or Ethereum. So the key differences are first the consensus mechanism that I talked about. So Hedera Hashgraph uses the Hashgraph consensus algorithm, which is based on gossip about gossip and virtual voting. This allows Hedera to achieve faster transaction speeds and higher throughput with a high level of security. Meanwhile, Bitcoin uses proof of work, another consensus mechanism where miners solve complex cryptographic puzzles to validate transactions and add blocks to the blockchain. Ethereum initially also used proof of work, but it transitioned to proof of stake. So where validators are selected to propose and validate blocks based on their stake in the network. Of course, the architecture differs in terms of speed and throughput. So a Hedera graph can process thousands of transactions per second, with finality occurring in seconds also. The architecture supports highly scalable dApps with low latency. Meanwhile, Bitcoin typically processes about 7 transactions per second, while Ethereum's throughput was around 30 transactions per second. So these networks still face limitations compared to Hedera's speed. Now, if we talk about the data structure, uh, Hashgraph utilizes directed acyclic graph structure, meaning transactions are linked in a way that allows them to be processed in parallel. So this is fundamentally different from the linear structure of a blockchain where each new block depends on the previous one. Hedera graph is designed with ABFT, asynchronous Byzantine fault tolerance, meaning that it can handle up to third nodes acting maliciously without affecting the network security. This makes the system highly resistant to attacks and manipulations. Bitcoin's proof of work provides security by requiring significant computational power, making attack costly. Ethereum's proof of stake, though more energy efficient, is still vulnerable to centralization risks depending on the distribution of stakes. Also, we can talk about the difference in terms of governance. So the governance in Hedera is centralized through the Hedera Governing Council, which is composed of well-known organizations from different industries. Meanwhile, both Bitcoin and Ethereum use decentralized governance, where decisions are made through community consensus and major upgrades. So often required widespread agreement among participants, miners, or stakers. So, in summary for you, Miriam, Hedera's Hashgraph's architecture offers faster speeds, greater scalability, and more energy efficiency compared to traditional blockchain, but it uses a different consensus model, a different data structure, and a unique governance approach. So let me know, please, if you found my answer clear. Otherwise, if it's still not clear for you, you can ask more questions. Okay, so I have another question that I already answered while responding to Miriam. What's the difference between proof of work and proof of stake? Okay. So proof of work is where miners solve complex cryptographic puzzles to validate transactions and add blocks to the blockchain. While proof of stake is where validators are selected to propose and validate blocks based on their stake in the network. So staking is like locking tokens or coins for a determined period of time. So you're not mining or you're not using computer powers to generate tokens. Okay, so you're just locking your tokens into the network. That's it, mainly. You don't need any energy or any computational power for that. So let me know, Valentine, if you found my answer clear or not. Also, Miriam, before moving on to the next part of the presentation. Okay, so another question that I haven't witnessed is how does Hedera ensure energy efficiency compared to traditional blockchains like Bitcoin? Okay, so Hedera Hash Graph ensures energy efficiency by using a radically different consensus mechanism, which reduces the computational resources required to process transactions. So Hedera uses the hash graph consensus algorithm, which, as I said, is based on gossip about gossip and virtual voting. So instead of relying on energy intensive proof of work or even proof of stake, Hedera's algorithm allows nodes to reach consensus efficiently without requiring complex cryptographic puzzles or large scale computational effort. This means that no mining is required. There is no need for mining in Hedera. All nodes communicate through the gossip protocol to agree on the order of transactions, which drastically reduces the need for massive computational power and energy consumption. Also, Hedera is designed for high transaction throughput with low latency. So the efficient structure of the Hedera, the hash graph network, allows it to process thousands of transactions per second with minimal resource usage, okay? Thus ensuring energy efficiency at a scale. Also, the architecture is designed to minimize energy consumption with nodes participating in consensus without the need for resources heavy operations. So it's an approach that leverages efficient communication and decision making methods to reach consensus without the large scale energy use associated with traditional blockchains. So also we can talk about the Hedera hash graph proof of stake hybrid model. So it's not fully proof of stake, but a part of the consensus process that contributes to energy savings as validators are selected based on stakes rather than computational effort with proof of work. So this reduces the need for continuous power-hungry calculations, unlike proof of work systems. So if we want to wrap up all of this, Barbara, I will tell you that Hedera ensures energy efficiency by eliminating the need for mining using a highly efficient gossip-based consensus algorithm and optimizing its architecture to process transactions quickly and securely without heavy computational demands. So I hope that you found my answer clear. So don't hesitate to let me know if it's clear or not in the chat. Also, Goldwares9 said, repeat the differences again, please. So I think you want me to repeat the difference between proof of stake and proof of work? Yes, it's clear. Thank you. Okay, very good. So I don't know if it's clear for you, Miriam, or not, regarding the question of how does Hedera's architecture differ from traditional blockchain? Okay, so quickly, if you want me to repeat the differences So it's easy. Bitcoin uses proof of work where miners solve complex cryptographic puzzles to validate transactions and add blocks to the blockchain. So this necessitates like computational power. They are called ASIC miners. So you need hardware to mine. Meanwhile, in proof of stake, validators are selected to propose and validate blocks based on their stake in the network. So you just need to lock in tokens into the network to participate to the proof of stake. So this is the difference, okay? Okay, all good for Barbara and Miriam. So let's go back to the presentation. In the next slides, I'll explain you why Hedera is different. Okay. So this sentence sets the stage for this journey. If you're coming from Ethereum, you might assume all public ledgers operate similarly. But that's not the case with Hedera. Hedera uses hashgraph consensus. It's not a blockchain, which eliminates many of Ethereum's limitations. For instance, Ethereum relies on miners and proof of work, leading to slower transaction finality and higher energy costs. Hedera, on the other hand, achieves consensus in seconds using a gossip protocol and ABFT, asynchronous Byzantine fault tolerance, ensuring security without the environmental footprint. There are good reasons Hedera doesn't copy Ethereum. It's built for enterprise needs, offering predictable fees and scalability that Ethereum struggles to match. So let's explore what this means for transaction finality. So consensus is 100% final in few seconds. We see a key advantage of Hedera. On Hedera transactions, finality happens in just 3 to 5 seconds with no risk of reversal. Unlike Ethereum, where you might wait for multiple block confirmations to ensure finality. There's no need to store transaction history to prove validity. Hedera stable proofs handle that. Plus, Hedera doesn't use blocks, so there's no block height or complexity to worry about. Each transaction gets a unique, fair timestamp, ensuring clarity and order. Imagine a financial institution settling cross-border payments instantly without the uncertainty of rollbacks. This speed and finality make Hedera a game changer for real-time applications. Let's now look at how Hedera handles high throughput. Okay, so the high throughput creates new challenges. Slide highlights Hedera's ability to handle 10,000 transactions per second. To manage this, Hedera dedups transactions using a unique identifier, the paying account plus valid start time. For example, a transaction ID might look like, I don't know, for example, 0.011, and you see arabesque, also like 8 other numbers, for example, 16, 45, 10, 61, 60, point, another numbers. So transactions also have a valid duration, and it's up to 120 seconds and must be submitted within this window, ensuring the network isn't overwhelmed. This structure prevents duplicates and keeps the system efficient, even at scale. For a business, this means processing thousands of payments per second without bottlenecks. Something Ethereum's gas limits can't handle. So the next slide, we'll see how Hedera's network structure differs. So why I said that Hedera structure differs? Because there are no miners and no leaders. So every node participates in consensus using the hash graph algorithm to reach agreement quickly. Transactions don't sit in a mempool waiting to be picked up. You can submit them to any node, and there's no prioritization based on fees. Hedera's fees are stable in USD and based on actual costs, not a highest bidder system like Ethereum's gas auctions. This predictability is a huge win for business budgeting for DLT solutions. Think of supply chain app processing thousands of updates daily without worrying about spiking fees. Let's now explore Hedera's path to decentralization. The so bootstrapping a proof of stake network takes time. And for now, Hedera's consensus nodes are permissioned, run by a governing council. You can't turn your own consensus node yet, except for local development. But you can use the testnet to experiment. Hedera's roadmap includes opening consensus nodes to a permissioned community. In the near future, a step toward broader decentralization. This phased approach ensures stability while scaling, unlike Ethereum's early days of centralization risks. For enterprises, this means a reliable network today with a clear path to greater decentralization. Let's see how Hedera approaches smart contract differently in the next slide. So, I think someone turned on his mic. So Odinga, please, if you can, if you can turn off your mic.
Yes.
Thank you very much. Okay, so let's go back again. So I said that now we'll see how Hedera approaches smart contracts differently. Now the smart contracts are good, but not good enough. Okay, so what does that mean? While Ethereum popularized smart contracts, Hedera takes a smarter approach. Hedera offers native multisig for secure transactions, plus services like HCS, Hedera Consensus Service, and HTS, Hedera Token Service, for low-cost, high-throughput operations. It also supports native atomic swaps, simplifying trades without complex code. Hedera Smart Contracts 2.0 natively interact with HTS, Hedera Token Service, and HCS, Hedera Consensus Service, optimizing performance. So what's the key takeaway here is to be strategic about using smart contracts and leverage Hedera's native features where possible. For example, a company issuing tokens can use HTS directly, avoiding the overhead of Ethereum's ERC20 contracts. In the next slide, we'll discuss how Hedera handles mutability. So, as we know, all DLTs are mutable. Account balances and contract states change, but Hedera introduced controlled mutability. Its entities like accounts and tokens have optional keys to approve changes, ensuring only authorized updates occur. This includes the ability to delete entities, a feature Ethereum lacks, giving businesses more control. For instance, a company can delete a compromised account to prevent fraud, something Ethereum's immutability doesn't allow. So, this flexibility makes Hedera more practical for regulated industries. Now, moving on to our final slide in the unlearning section. So, it covers Hedera's entity management. All entities like accounts or tokens have a unique identifier, a shared real number, not a public key. They are subject to rent, ensuring network isn't cluttered with unused entities like Ethereum's permanent storage. Auto-renew periods manage this process efficiently. Queries uh, to consensus nodes have a cost. And also, uh, of course, they have a cost except get recept and get balance, which are free, making basic operations accessible. So this structure keeps Hedera lean and cost effective. For a developer, this means predictable costs and clean network build on. So to quickly wrap up what we saw in this section, we've unlearned Ethereum's assumptions and seen how Hedera Hashgraph redefines DLT. From instant finality and high throughput to stable fees and controlled mutability, Hedera is built for enterprise needs. Its unique approach to consensus, smart contracts, and decentralization is built for this is a powerful choice for your organization. So now that we've covered the whole unlearning session, I want to see if anyone have questions regarding this. So I'll quickly take a look at the chat. So if you have question regarding unlearning and how Hedera is different from Ethereum, you can just ask your question in the chat. So I'll give you a few minutes. If it's clear for you, don't also hesitate to mention that is clear so that I can know if we can continue the presentation or not. So take a few minutes to drop all that into the chat. Okay, so we have a question from Valentine. I've heard you mentioning a word consensus. What does it mean? So usually the word consensus refers to a general agreement or collective decision reached by a group of individuals or entities. So in the context of blockchain or distributed ledgers, consensus specifically refers to the process by which all participants in the network, often also called nodes, agree on the validity of transactions and the order in which they occur. Okay? So, as I previously said, there are various consensus mechanisms in different blockchain systems, such as proof of work, which is used by Bitcoin, proof of stake, which is used by Ethereum, and hash graph, which is used by Hedera. So, in short, consensus in blockchain refers to the collective agreement that ensures the network operates smoothly and securely by validating and confirming transactions. So I hope that you found my answer clear. So let me know if it's clear or not. Otherwise, tell me what is clear, still not clear for you, Valentin. Okay. So I'll give you also few more minutes to think about other questions you want to ask for the section on learning. Also, please, if everything is clear, mention that it's clear so that we can move on faster to the other parts of this Hedera training session. So we have another question from Abir. Is Ashgraph light-weighted compared to proof of work? So yes, Ashgraph is light-weighted compared to proof of work in several significant ways. So first, it's light-weighted in energy efficiency. So the Ashgraph consensus, as I said, uses gossip about gossip combined with virtual voting to achieve consensus. So as a result of this consensus, it doesn't require energy intensive computations, making it much more energy efficient. On the other hand, proof of work systems like Bitcoin, we have miners competing to solve complex mathematical puzzles to validate transactions. So this process is computationally heavy and consumes a large amount of electricity, especially as the difficulty of the puzzles increases over time. So here we can talk about the computational requirements. Nodes in a hash graph network don't need to perform resource-heavy computations. Instead, they participate in the gossip protocol and virtual voting, which are computationally light. So proof of work needs specialized hardware. So as I mentioned, for example, ASICs for Bitcoin. If we also compare scalability and speed, so since Hashgraph does not rely on proof of work or its similar intensive mechanism, it can handle thousands of transactions per second with lower resource consumption. So this makes it scalable without the heavy computational load that typically slows down proof of work based system as they grow. Finally, we can talk about the environmental impact. So as I said many times, since Hashgraph is not reliant on energy consuming mining, it has significantly lower environmental impact compared to proof of work based systems. So the protocol is designed to be efficient with fewer hardware and energy requirements. So if you want me, Abir, to recap all of this, Ashgraph is considered more lightweight than proof of work because it doesn't require heavy computational work or mining, leading to lower energy consumption, faster transactions, and better scalability. So I hope that you find my answer clear. If you still have more questions, you can drop them into the chat. I'll give you few more minutes for the other participants who want to interact or ask questions regarding the first part of this presentation before diving into more details during this training session on Hedera. Okay, so Afrika, can you please mute yourself because I think you turned on your microphone. Okay, another question from Abir. Any idea about Hashgraph scalability and security issues like forks in Bitcoin. Okay, so as I said before, Hashgraph offers several advantages when it comes to scalability and security compared to traditional blockchain systems like Bitcoin. However, like any technology, it also has its own set of challenges. So the network can process thousands of transactions per second if you are talking about scalability and high throughput. Meanwhile, Bitcoin can only process 7 transactions per second. So the scalability is due to Hashgraph's consensus. Can also talk about the parallel processing since Hashgraph uses DAG, directed acyclic graph. So which is structure rather than linear blockchain. This results in significantly higher throughput and scalability because transactions don't have uh, don't have to be processed one after another. From the security part, we can talk about the ABFT, asynchronous Byzantine fault tolerance, one of Hedera's key security features. It is its consensus model, which ensure that the network can tolerate up to 1/3 of nodes being malicious or faulty without compromising the overall security of the system. So, in my opinion, this is a high level of security, especially compared to traditional blockchain systems. So, now, if you want to talk about forks and forking, so let's first talk about forks and Bitcoin, okay? Because I think many of the participants don't know what forks means. So, in proof of work blockchains like Bitcoin, forks occur when different miners find a valid block at roughly the same time. So, this leads to a temporary divergence in the blockchain. The network has to resolve the fork, by choosing the longest chain, the one with the most computational work as the valid one. So forks in Bitcoin can cause temporary splits, also transaction delays, and the possibility of double spending attacks. If now we talk about forks in Hashgraph, I think that Hashgraph doesn't suffer from forking issues because its gossip protocol and its consensus mechanism. So in Hashgraph network, there is no longest chain rule as we find in Bitcoin, as it doesn't operate in the same block by block structure. Instead, all transactions are recorded in the DAG, directed acyclic graph, and nodes quickly reach a consensus on the order of events without creating competing branches. So this means that Hashgraph structure avoids the need to resolve forks like in proof of work systems. When nodes gossip about events and virtual voting occurs, they rapidly reach an agreement ensuring no forks or chain splits. Okay, so in summary, Abir, I think that Hashgraph provides better scalability and avoids forking issues compared to Bitcoin's proof of work system. And also from a technical perspective, Hashgraph is more scalable and secure in terms of, as I said, of avoiding forks and also maintaining consensus compared to proof of work based blockchains. So I hope that you find my answer clear. If it's not really clear in terms of scalability, security issues, and forking, you can drop it in the chat also. Okay, very clear. Thanks. Thank you, Abir, for your interaction. Another question from Barbara. I'm curious to on I'm curious on the role of Hedera on real world assets. All right. So if you go to the website of Hedera, you'll find a whole section about real world asset tokenization on Hedera. Okay. So Hedera platform simplifies the process of tokenizing real world and digital assets, making them liquid, frictional, and transparent. So, as I said previously in the informative sessions, uh, Hedera is regulatory compliance, meaning that if RWA tokenization may necessitate account level configurations to ensure regulatory and compliance adherence, everything is already set up. Hedera enables token issuers to define account level KYC verification and freeze. Also, token supply management, transfer, along with AML, so the anti-money laundering, who checks to adhere to regulations and more. So if you want some case study, I can mention Aberdeen. So they partnered with Hedera, and they said that it was perfectly aligned with their commitment to financial inclusion and creating a more equitable investment landscape. So another platform uh, developed on Hedera for tokenization of assets and data integrity is Dovu. Also Diamond Standard, which is a fungible token based on Diamond Standard's physical coins and bars. So at the end of the session, I'll send you the link to the website so you can check it. So I don't know, Barbara, if my answer was clear or not. Otherwise, we have another question from Odinga. Is Hedera fully centralized? So Hedera's graph is not fully centralized, but it does have a unique governance model that is different from many other decentralized blockchain networks. So Hedera is governed by a governing council which consists of, I think, 39 global organizations, including big corporations such as Google, IBM, Boeing, and Tata Communications, for example. So it's a centralized governing council because these members play an active role in governing the network, making decision on protocol upgrades and setting policies for the for the Hedera network. But the nodes are decentralized. So despite the centralized governance model, Hedera's network still operates with a decentralized set of nodes. So these nodes are run by council members as well as other participants, and they work together to secure the network and process transactions. So let's say that Hedera is partially centralized in terms of governance due to its governing council. So an answer for you, Odinga, it's not fully centralized because, as I said, Hedera is decentralized in terms of its nodes, operations, and its consensus mechanism that ensures high security and fault tolerance. So the centralized governance model was chosen to provide stability and enterprise adoption. So while it isn't fully centralized, as you know, like Bitcoin or Ethereum, it isn't entirely centralized either. So it falls somewhere in between with a hybrid model that balances centralized governance and decentralized operations. So I hope that you find my answer clear, Odinga. If you still need more clarifications, you can just drop another question into the chat, okay? Okay, now that I think I've answered a lot of questions, it's time to go back to the presentation, okay? So Odinga said, it's clear, sir, thank you. Thank you for your interaction and for all participants that try to ask some questions to understand and learn more about the Hedera network. So let's go back to our presentation now. So I think that I got disconnected. I'll share my screen again.
Yes. Yeah. Welcome back, Mr. Yusuf.
Thank you.
Happy to have you with us.
Happy to have you too. Okay, so if someone can remind me where I have stopped, because I haven't noticed that I got disconnected, please drop it into the chat, guys. Page 77. Okay. So now we'll talk about the keys management, right? All right. So Hedera's approach to key management is a critical part of its security model. So as we can see here in this slide, Hedera supports both ED 25519 and also ECDSA keys natively, giving developers flexibility in cryptographic operations. For example, you can generate an ED 590 private key with these functions in the slide down below, okay? So now let's see how this dual support works, okay? So this dual support ensures compatibility with various cryptographic standards, making Hedera a versatile choice for secure applications. Let's see how Hedera handles multi-signature setups now. Okay. Hedera allows any key on an entity to be a single key, a list, or even a threshold key list, offering robust multi-signatures capabilities. So you can create a key list like this in the slide and set threshold, say 2 out of 3. You can also nest key lists for more complex requirements. So this flexibility is perfect for businesses needing multi-party approvals, like, for example, a financial institution requiring two executives to sign off on a transaction. Let's now look at how Hedera defines accounts. As you all know, accounts are the first entity that are identified in Hedera. Let's first understand how they are identified. So it's easy. Accounts have an identifier by shard.real.number format. For now, shard and real are both 0, and the number is assigned by Hedera when the account is created. Accounts hold cryptocurrency HBAR and optionally tokens, serving as the foundation for all the interactions on the network. This clear structure simplifies account management for developers. And now let's see and dive deeper into account properties. Okay, so first we have the key property that defines which key must sign. Sorry again, guys, for the delay. I think I got disconnected again. So we were talking about account properties, okay? So first, the key property defines which key must sign each transfer out of the account. If receiver SIG required is true, this key must also sign transfers into the account, adding an extra layer of security. The initial balance sets the starting amount of tiny bars in the account, ensuring it's ready for transactions. Finally, the memo field allows a UTF-8 encoded note up to 100 bytes for metadata, like labeling an account for a specific purpose. These properties give businesses precise control over account behavior. Let's continue more with account properties. Okay. The max automatic token associations defines the maximum numbers of tokens an account can implicitly associated with, defaulting to 0 and capping at 1000. This prevents unwanted token associations, keeping accounts manageable. The auto-renew period determines how often the account is charged to extend its expiration date, between 1 and 3 months. If the account lacks funds to renew, it's deleted after expiration. This ensures the network stays clean and efficient, a big win for long-term scalability. Now let's see how to create an account. So here's a simple example of code to create an account in this slide. So this code generates a key, creates an account with an initial balance of 10 H bars, as you can see, and logs the new account ID. It's straightforward and secure. Make an account creation accessible for developers like you building on Hedera. In the next slide, we'll see how to update an account. So this slide shows how to modify an account. Here's how to update the account memo in this code in the slide. So this process, signed with the account holder's key, ensures Only authorized updaters are made. It's a simple yet powerful way to manage account metadata, like updating a label for corporate account. Another example of updating an account's key, as you can see here in the slide. So we have added an SDK thing, so it has no impact on the network. It's also asynchronous, so it's signed with the account holder's key. Now, an example of creating an account from a public key right here. So as usual, first we have the generation of the keys. Then we are transferring some HBAR to the new account. So in this example, we have transferred 10 HBARs. So that's it mainly. In this section, we've covered Hedera Hashgraph's key management and account creation features. So from multi-signature support to account properties and updates, Hedera's design priorities security, flexibility, and efficiency, making it an ideal platform for enterprise solutions. So I'm happy to take any questions regarding this part of the presentation. So as usual, don't hesitate to drop them into the chat. I'll quickly have a look on the chat. So was the part of key management and account creation clear for you? If you have any question, don't hesitate. Thank you, Amani, for your interaction. So you can either turn on your microphone and directly ask your question, or you can type it as usual in the meeting chat. So I'll give you a few minutes to ask your questions. Otherwise, as usual, if it's clear, just mention it so that we can continue. Repeat on the account creation. Okay, sure, yeah, we can have another dive on that. I think it was on slide 84, yes. Okay, so it started from here, Dolphin, okay? So accounts are the first entity in Hedera. They are identified by a shard.realm number format. So as I said, for now, shard and realm are both 0, and the number is assigned by Hedera when the account is created. Accounts hold cryptocurrency HBAR, the native token of Hedera, and optionally tokens, serving as the foundation for all interactions on the network. So this clear structure simplifies account management for developers and engineers. So now let's dive again into the account properties. So first, the key defines which key must sign each transfer out of the account. Of course, if receiver SIG is true, this key must also assign transfers into the account, adding an extra layer of security. The initial balance sets the starting amount of tiny bars in the account, ensuring it's ready for transactions. Finally, the memo field allows a UTF-8 encoded note up to 100 bytes for metadata, like labeling an account for specific purpose. So these properties give businesses precise control over account behavior. Here, other properties such as max automatic token associations and also auto renew period that determines how often the account is charged to extend its expiration date, which is between 1 and 3 months. Okay, now this slide walks us through the process of creating an account. So here's an example of how to create an account. So this code generates a key. It creates an account with an initial balance of 10 H bars and logs the new account ID. So it's straightforward and secure, making account creation accessible for developers building on Hedera. So in the next slides, I covered the updates. So I don't know if you also want to check the update again or not. And also tell me if the account creation steps were clear for you or not, please, Dolphin, okay? Also, the other participants, don't hesitate to ask your questions in the chat. And if it's clear, also mention it so that we can keep going on our presentation. Okay, Dolphin said it's clear. I'll give you a few more minutes to think about questions. Otherwise, we will continue the presentation. Okay, so no more questions. I think that we can keep going on our presentations. I'll leave the last 10 minutes for a Q&A session. So we've covered all this. Okay, so now let's talk about the SDK part, like the SDK that are accessing to Hedera, okay? So first, let's define an SDK client. So the SDK's client is both a provider and a signer. It provides access to the Hedera network and signs transactions. HEAP 338 is introducing external signers and providers. So you will find the code down below in the slide. You have two choices. The SDK client also holds a list of Hedera consensus nodes per network. This can be overridden. For example, to bypass non-working node with this type of code example. The SDK client takes an operator ID and an operator key. The operator ID is the account ID which will pay for transactions, while the operator key is the private key of the account. Down below, as usual, a code, an example. So, for example, here the client takes for testnet. We have the account ID. We also have the private key and an operator at the end. The SDK client picks a random node, then it sets up the transaction ID, and finally signs on behalf of the operator ID, as you can see in the code below. So first it picked a random node, then it set up the transaction ID. Here the example was to transfer one H bar, and finally it signed on behalf of the operator ID. We can also talk about overriding node and transaction ID. with this example. So the first part was to specify paying account by using client time for valid start. The second part was to specify paying account while using custom time for valid start. After that, the override the transaction ID, and finally override the target node, as you can see. So the client sets up default max transaction fee and max query payment. It can be overridden at the client level or also at individual transaction and query level. Now let's move on to the crypto service before going through the Q&A session. So as I said before, the H bar is the native token of Hedera. So the crypto service supports exchanging H bar between accounts. So H bar, the denominations are in gigabar, megabar, kilobar, H bar, millibar, microbar, and tiny bar. Okay, so you can exchange to or from multiple accounts from at once. So the account create transaction is 2 TPS and the account balance query is unlimited. Okay, so here's an example on how to transfer to a single other account. In this example, we have transferred one H bar. Here, how to transfer from one account to two others. So an account has sent two H bar, one H bar to the first account and one H bar to the second account. Now another example that shows how to transfer from two accounts to one other. So that's it mainly for today. I think we'll finish right here. So next time we'll talk about the token service. By that I mean managing fungible and non-fungible tokens. So thank you very much for your attention, dear participants. And now I want to see if you have some questions regarding the overall presentation. So don't hesitate to ask your questions. Try to be curious. If you think that you have some unclearance, don't hesitate to ask. You can also turn on your microphone and interact directly with us. Otherwise, I'll drop the link of our Discord server. So we have a community room where you can also ask your questions anytime you want. I'll be there to answer, and you can also interact with our community. So today we are more than 900 members in the Discord server. Now I'll leave you some time to ask your questions in the chat. As I said, you can also raise your hand and turn on your mic. So Amani said, thank you for your presentation. Thank you for joining us today, Amani. Thank you for your time. Yasin is asking, there is a record for this session. So Talel, I think there is a record, right? So this session is recorded. Another question from PM. Thank you for your presentation, sir. You are welcome. Thanks for joining us too. Okay. How do I actually use the SDK in use case? Okay, so if you can first clarify what type of use case you're interested in for using the Hedera SDK. As you know, there are way too many use cases in Hedera. So, for example, do you want to create a cryptocurrency transaction, or you want to build a smart contract or dApp? Or also if you want to store files or data using a data file service? Are you even aiming to create or manage NFTs or token? So if you can clarify that. Okay, super. Yasin, I think we will upload it to our YouTube channel. So I'll send you the link of our YouTube channel. You'll find also many other viable videos. So each Friday we are doing uh, an educational Friday event. So we have covered several topics about blockchain, cryptocurrency overall. So I'll send you right now the link of our YouTube channel so that you can check it the next few days, where you'll find hopefully the record. Okay. So here is it. Barbara is saying, thank you for the presentation, sir. Thank you also for coming and joining us, Barbara. Please share the RWA links. Thanks again. Yes, sure. I'll share it with you right now. So you just need to go to the Hedera official website. And then you click on use cases. And in use cases, you'll find many use cases such as data integrity and AI, sustainability, consumer engagement. So it's not only RWA tokenization, the only use case of Hedera. There is also decentralized identity, for example, DeFi, payments, NFTs, many other functional use cases, okay? So I'll send you the link of the real world assets use cases. So here it is. I dropped it into the chat. Grace is saying, thank you for the session. Thank you, Grace, for coming, and hope to see you again. Don't hesitate to join us in our Discord server so that you can ask any type of question you need anytime. So, any more questions, guys? Or everything is clear?
Cool, guys. So if you have any question or anything that appears in the middle of the process of certification, please do not hesitate
Yes, absolutely.
to share it on Discord or on our Telegram or send us an email, and then that way we can make sure that you'll get the right answer. From
Absolutely.
another side, I would like to mention for people that are interested by continuing on this path, we have the third session on Saturday at 11 a.m. We will share with you the link. and in that way it's gonna be easy for you to follow up. Yes, Yasin.
Hi everyone. Uh, I want to get some information about the summer bootcamp in Switzerland or Cape Town.
Yes.
Sorry, I
So,
can.
as I mentioned it in the beginning, I think everyone here got an email either from my side or from Aya. So we have an extension of deadline for tomorrow for the summer boot camp at Switzerland. So if you want to be part or to be selected to go to Switzerland, you should finish your certification by tomorrow. And for people that are willing to join us on South African journey, they can continue till the 30th of April. And for the Hedera hackathon, you should finish it before the hacking date.
Before tomorrow.
So ideally, you get it to the today or tomorrow. And after that,
Oh,
like you have the second chance to join the South African summer boot camp and the Empower X hackathon, either by the 30th of April or the 2nd of May.
okay, thank you.
Perfect.
And the certification, I will get it from
From the
from
same website, you will
hedera.com.
find by finishing the certification, you will get it directly.
Yes.
And if anyone has an issue with downloading the certification, just mention us to us. No, I repeat.
In the site, I go where?
You go to the exam section, pass your exam, and you will get your certification by succeeding the exam.
Okay. Thank you. And after I send the certification to who?
No, no, you will have it in our database. You don't do anything, just get your certification. We'll have
Okay, okay,
everything on our database.
okay. Thank you very much.
So once again,
Welcome.
thank you very much, guys, for joining us today. So it's already been 2 hours. I think it's time to close this session and hope to see you once again next time on another training session on Hedera. Thank you very much, guys, and see you soon.
Thank you and have a nice evening.